Now let's look at the concept of cofactor, transpose, adjoint and inverse of a 2 by 2 matrix. Now we are limiting our discussion to 2 by 2 matrices because that is what is required of us for the purposes of JAMB. So now let's talk about cofactor. The cofactor of the ij element of A will be defined as -1 power of I over j times the determinant of the submatrix formed by omitting the ith row and the jth column of A. We put these cofactors in the matrix we call the cofactor matrix. Let W be the cofactor matrix of our 2 by 2 matrix. So what does it mean? So to find the cofactor of a matrix, so what do? We just say is equals to, let's consider a matrix which is equals to A, B, C, D. So now we know the position of this matrix A. We know that the position is 1 1, meaning that it is in row 1 and column 1. Position of this B is 1 2 in row 2 and column in row 1 and column 2. Position of this is 2 1, row 2 and column 1, and the position of this is 2 2. So to get the cofactor, the first thing we do is that we find the -1 raised to power the sum of the position. So for this, the position is 1 1, so -1 raised to power of 1 plus 1, and we multiply it by the determinant of A. So to find the determinant of A, we just cross here and we cross here, and what value is left? D is left. So the same thing applies here. We have -1 to the power of the position is 1 plus 2, and when we cross out B like this and like this, we are left with C. So when we do everything, it results in this. So that's how this table is being filled up, or this matrix is being filled up. So you know that -1 to the power of 2 is 1, so you have D. -1 to the power of 3 is -1, so you have minus, and you have your C here, and you have -1 to the power of 3, which give me minus and my B here, and -1 to the power of 4 times A will give me A here. So as you can see, when you have a matrix A, B, C, D, the cofactor is given as what? D minus C, B, A. So what does it mean? That means to find the cofactor of a 2 by 2 matrix, all you need to do is to switch place of the diagonals. So this diagonal here, you add A here up and D down. So you bring D up and you take A down. So you have D up here and you have A down. Then the same thing you do to the second diagonal. You have BC. So you bring B down and you take C up. But in this second diagonal, you now multiply both terms by -1. So you now have what? Minus C and minus B. It's really important that you learn this trick, because this will really save you a lot of time when you are trying to answer questions that have to do with cofactor. So again, what do? For the first diagonal, you just switch the elements in those cells, while for the second diagonal, you switch the element, but you also multiply each element in the cell by -1. So let's take a look at what I'm talking about. So now we're told to find the cofactor of this matrix. So what is the first thing I have to do? The first thing is I have to switch the diagonals. So when I switch the diagonals, this first diagonal here, so I bring 4 up and I take 5 down. So I have 4 here and I have 5 here. I do the same to this diagonal. I bring 3 down and I take -1 up. So I have 3 down and I have -1 up. But I now multiply this second diagonal by -1. So when I multiply both by -1, what does this give me? I'm now left with 4. -1 times -1 gives me 1. 3 times -1 gives me -3, and I have 5. So the cofactor of this matrix is 4 1 -3 and 5. To recap, for the first diagonal, you just switch the cells, the elements in the cells, while for the second diagonal, you switch the elements in the cell, but you change the sign. So here you add a -1, so it becomes 1, and here you add 3, so it becomes -3. Now let's talk about the transpose of a 2 by 2 matrix. So the transpose of a matrix is obtained by converting each column to row. So to find the transpose of a matrix, what I'm doing in essence is I'm writing the columns as row. So for the first example here now, we are given that A is equals to 5 3 -1 and 4, and we are told to find the transpose of matrix A transpose. So the transpose of A will just be writing the column as rows. So this is the first column and this is the second column over here. So I'll write the first column as my first row. So my first column is 5 and minus 1. So I'll write it as my first row, which is what? 5 and minus 1. My second column is 3 and 4. But now write it as my second row as what? 3 and 4. So this is the transpose of this matrix. Second one, we are given that B is equals to 4, 0, 3 and 1. I was told to find the transpose of B. So the transpose of B will just be equals to changing. If I change the first column here is what? 4 and 3. So I change it to my first row. So it becomes 4 and 3. My second column here is what? 0 and 1. So I change it to my second row and that becomes 0 and 1. So this is the transpose of B and this is the transpose of A. So to find the transpose of a matrix, you just write out the columns as row. So column 1 becomes row 1, column 2 becomes row 2 and so on. So now onto the adjoint of a 2 by 2 matrix. The adjoint of a matrix is obtained by transposing the cofactors of the matrix. So what does it mean? It means that to find the adjoint of the matrix, the first thing you need to do is to find the cofactors of the matrix. Once you find the cofactors, you just find the transpose of the cofactors and that will be equals to the adjoint of the matrix. So now let's try to find the adjoint of this matrix. So the first thing we have to do is find the cofactor. So now I've said that the cofactor, to find the cofactor, what do? You just switch the diagonals. So here you have 5 and 4, so it becomes what? 4 here and 5 here. And here you have what? 6 and 3. So it becomes what? 6 comes up while 3 goes down. And you now multiply this term by minus 1. So you now change the sign, minus and minus. So this is the cofactor of the matrix B. So this is the cofactor. So now the adjoint of the transpose, the adjoint of the matrix B is equals to what? The transpose of the cofactor. So what does it mean? It means that I just need to find the transpose of this cofactor. So to find the transpose of the cofactor, I just change the columns to row. So in my first column, I have what? 4 and minus 3. So what? My first row will now be made up of what? 4 and minus 3. My second column is made up of what? Minus 6 and 5. So my second row will be made up of what? Minus 6 and 5. Alternatively, another way to think about the adjoint is that to find the adjoint of a matrix, you just switch the element in the first diagonal as we did there. So you just switch this over, which is the same thing as having what? 4 and 5. But for the second diagonal, you just leave them as they are, but you change the sign. So instead of having 3, 6, you just have minus 3 and minus 6. So that is another way to think about the adjoint or the procedure. You turn around or you interchange the first diagonal, you bring 4 up and you bring 5 down. But for the second diagonal, you just leave the elements that they have, but you just change the sign. So if it was a plus 3 that was there, it becomes a minus 3. So the plus 6 that it becomes a minus 6. If it was to be a minus 3 that was initially here, it becomes a 3. So to recap, to find the adjoint of a 2 by 2 matrix, you just interchange the first diagonal. So you bring 4 up and you bring 5 down, while you leave the second diagonal the way it is, but you change the polarity. The reason why I'm mentioning this shortcut is because it really saves you a lot of time when you are trying to solve real questions. So let's talk about the inverse of a matrix. So the inverse of a matrix is the product of the inverse of its determinant and its adjoint. So let's look at this matrix now. Let's find the determinant. So let's consider a matrix A in which you have what? A, B, C, D. So now what will be the determinant of the matrix A? That is pretty straightforward. We just multiply the first diagonal. We have what? AD minus multiply the second diagonal BC. So we have AD minus BC. What about the adjoint of A? So as I say, the adjoint of A will just be equals to interchanging the first diagonal. So I have D here and I have A down, but I leave the remaining diagonal as it is. So I have B here and I have C here, but I change the polarity, so I just add a minus to both. So now the inverse of a matrix now is given as what? the inverse of its determinant, 1 over the determinant times what? The adjoint. Product of the inverse of determinant and its adjoint. So now the inverse in this case, 1 over the determinant we have found to be what? AD minus BC, and the adjoint we have found to be what? D minus B, then minus C and A. So that is how this formula came about to be. Again, it will be very useful if you memorize or you understand this formula so that you can easily and quickly solve questions. So let's look at an example. Here we are told to find the inverse of the matrix. So you know that what? The inverse of a matrix, the inverse of a matrix B is equals to 1 over the determinant of the matrix times the adjoint of the matrix. So we first have to find the determinant of the matrix. So the determinant of B will be equals to, so you have what? Minus 1 times 7, this diagonal here, then minus, you have 4 times 3, the other diagonal there. So you have minus 1 times 7 minus 4 times 3, and that gives me what? Minus 7 minus 12. And what does that result in? That is minus 19. So the determinant is minus 19. The second thing is to find the adjoint. We know that the adjoint of B will just be equals to, I switch the first diagonal. So the first diagonal here, I'm going to have what? Minus 1 and 7, while I leave the second diagonal as it is, 3 and 4, but I change the polarity. So here is going to be minus and here is going to be minus. So the inverse of A is equals to 1 over the determinant. 1 over the determinant is minus 19 times the adjoint, and the adjoint we have found to be what? Minus 1, minus 3, minus 4 and 7. So this is the inverse. And another way of doing it is we can write this and multiply all the cells here by the scalar minus 1 over 19. And if we do that, minus 1 over 19 times minus 1 becomes, here becomes 1 over 19, here becomes 3 over 19, here becomes 4 over 19, and here becomes minus 7 over 19. So we can either write it out in this form or in this form. So to recap, the inverse of a matrix is the product of the inverse of the determinant times the adjoint. You now have to find the determinant of the matrix. You just multiply the first diagonal and we subtract the second diagonal from it. So we have 7 times minus 1, which is minus 7, minus 4 times 3, which is 12. Minus 7 minus 12 gives us 19. Secondly, we have to find the adjoint of B. So the adjoint of B is going to be, we turn around this first diagonal, so we bring the minus 1 up and bring the second down, but we leave the elements in the second diagonal as they are, but we reverse the sign. So instead of having 3, we have minus 3, and instead of having 4, we have 4. Then we multiply the inverse of the determinant by the adjoint of the matrix. That gives us the inverse. So the inverse of the matrix is given by this. And we can multiply each element here by the scalar minus 1 over 19 to also get this. So this pretty much sums up the idea of inverse of a matrix. So I would suggest that you try to look for other 2 by 2 matrix and try to determine the inverse using this shortcut method. And if you can do that, then solving JAMB question relating to the inverse of matrix will be really fast for you to compute.